Good morning, people. How are you this morning? Thank you, Esther and Patrick. Thank you so much. Right. Good morning, Basil. How are you? So, as we start the lesson, I want us to do a small lab. So, we're going to create a VPC today. We are going to start off where Patrick left us last week. And I'll combine the class with the one for good morning, Brian. So we are going to start off where Patrick left us last week on Friday. Nilisema mmechoka. Unfortunately, masomo ikuchoka, so we have to proceed. And today we'll be combining subnetting and networking on the cloud. It's going to be a lot of work, but I know you guys, you're sharp. So who can tell me what is a VPC? Somebody, you can unmute too. Somebody tell me what is a VPC. I want to see if you understood, Jana. Yes, it's a virtual private cloud. And Patrick told us it has a few things. Yes, it's a private space on the cloud. Patrick told us it has a few things. Do you remember what encompasses the VPC? Anyone? Do you remember what is included in the VPC? Yeah, public and private VPCs. Yes, Internet Gateway, good Felix. Another thing. Another thing. One must specify the setup block. Yes. Subnets. Yes. Yes, Daniel. Gideon. Yes. All right. Anything else? Something you're leaving out. Remember when Patrick was telling us about regions? Huh? Availability zones. Right? People, did you understand last week's lesson? Because I do not want to move on. Yes, Knuckles and Security Group. Yes, Felix. Anyone? Might have to repeat a few things so that to see wachane nyuma. All right. Let me just share my screen. People, did you understand about IP subnetting? Let me just start here because no one is talking to me today. All right, let's start with IPs. We said there are public IPs and there are private IPs. So you have a network. Imagine that you have a big chunk of land and you have a network that you want to subnet, you want to divide into smaller pieces, right? Now, in the cloud, in the VPC, you are allowed to break down your networks into smaller pieces, but there's also a limit. There's how high you can go and how low you can go. And the biggest subnet that you can have is /16, and the smallest is /28. All right. Now, what are IP addresses? Let me just start from there. I remind you from last week because now we might need to refresh our minds kidogo. Let me just give you my notes. Might be easier to understand. All right. So we said there are public IPs and there are private IPs. All right. And the public are the ones that have direct access to the internet, and people from the internet can view your IP address and what is hosted on your IP address, right? Now, for private, this is hidden from the internet, all right? Now, we said a VPC is a virtual private network, but on the cloud. So think of VPC as your very large network, right? Now, if you have a large network and you have many devices, remember like last week, we gave an example of we have a printer, we have a scanner, and we have, say, 15 desktop computers, and we have created our network in the office. What can we do? Number one, with our big network, we need to subdivide it into smaller networks, all right, called subnets. And we said for things that are shared in the office, for example, like a printer and a scanner, they're going to have a static or dynamic IP. Tell me, guys, for resources that are going to be shared in the office, like a printer and a scanner, should they have a static or dynamic IP?
Static.
Some static, right? Because you do not want the IP address, very nice. You do not want the IP address to keep on changing. All right. So In our office, we have the scanners, we have this everything that you want now to give the IP address, all right? Now, what do? We need to subdivide our network into smaller networks, okay? And there are some, okay, so to divide it, to subdivide the network into smaller networks, it's what we call subnetting, all right? All right? Now, and remember when you were learning about changing IP addresses to binary, we said that an IP address has 4 octets. In the 4, if it's an octet, octet is a base, it's 8, right? And if there are 4, 8 times 4 gives you base 30 slash 32, right? Now, all these parts of the IP address, 8 of each, so 8, 8, 8, 8, 8 times 4 is 32, all right? So each part has 8 bits. Total, we get 32 bits for the IPv4 address, all right? And remember we said that each octet runs between 0 to 255. Do you guys remember? So if it's like this is 0 to 255, 0 to 255, 0 to 255, and 0 to 255, right? So each part of an octet, so if it's, for example, 192.168.1.10, dot 10 has it can range from 0 to 255. And knowing this, then we can be able to actually be able to give the best CIDR block to our resources. Okay, higher. And we also said there's a network part and there's a subnet and there's a host part. There's a network part and there's a host part. For example, let's look at this IP address, all right, 192.168.1.10. It has a subnet mask of 255.255.255.0. This means that the 10 is the host part. But because these others are full, they are 255.255.255, it means they are the network part. Guys, have you understood? When it comes to subnetting and you want to know which part of the network can I subdivide, how many IP addresses can I get from this IP, you're going to get a subnet mask, all right? uh, and Patrick showed us when you are doing, if you're going to run a command of ifconfig, especially if you're in Windows, it's going to give you your IP address. All right. If it gives you IP address, it's also going to show you your subnet mask. If it shows you your subnet mask, you're going to know that the part that has a 0, any part that has a 0 is a host. But any part that has the full 255.255.255, any part with a 255, it's the network. All right. Now, with this knowledge, we can be able now to come and create CIDR blocks. All right. So why subnet? We said it is important if you have resources and you'd like to, if you have maybe devices and you want to be able to give them IP addresses to be able uh, to um, to incorporate them in your network, you should be able to know the devices that you have, know the subnet that you have, and the IP addresses that you can get. And heads up, guys, I have a cold. If my voice is froggy, forgive me for today. All right. So subnets, we say that subnets are important so that you can know the number of IP addresses you can give to your devices. And it's also important that you do not waste IP addresses. Later on, when we are diving into VPC totally, you're going to understand that some IP addresses are paid for. And if you provision, say, an elastic IP address, we said an elastic IP address in the cloud is a static IP address. If you provision extra elastic IP addresses that you're not using, you're going to be charged for them. Okay, so it's important for you to know um, the subnet that you have, the number of IP addresses that you get, so that you don't over provision or under provision. All right, now um, let's take a good example of let me just push this down to get one table. All right, so now let's see our IP addresses and their subnets before dividing them out. All right, so we have the first one. We had a 10 dots. All right, so the first one, this with this example, we can take an example of this subnet. All right, so we have parts of the subnet. For example, we have this IP address code. We have this IP address of 10.0.0.1, right? And it has a default subnet of 255.0.0.0. And we said in a subnet, anytime that you see a zero, it means the zero is for the host and the 255 is for the network. Okay, so the network has all these three octets that you can subdivide. All right. If we take an example of 172.16.0.1 and it has a subnet of 255.255.0.0, it means the first two octets are for the network and the last two are for the host. All right. So these are the ones that you can be able to subdivide. In taking an example of 192.168.1.1, it with a subnet of 255.255.255, the network has three octets, but the host has one octet. Okay. Now, in IP addresses, we have classes. All right. We have class A. The first three classes are class A, class B, and class C. And class A starts from 10.0.0.0 to 126.255.255.255. Sawa. And then we skip 127, we go to 128. In class B, we have 128.0.0.0 to 191.255.255.255. And then for class C, we have 192.0.0.0 all the way to 23.255.255.255. Who can tell me why we do not have 127 here? Somebody. What do we use the IP address for 127 for? Say 127.0.0.1. What do we use it for? Somebody. I know you people, you know, especially if you've developed a full, yes, it's for local host. All right. 127 is for the local host. Yes. Good. So, yes, it's for the local host. 127 is for the local host. So, class A, it usually has the largest networks. And when we go to AWS, you're going to realize that most of the time we use class A, right? For your home networks. Remember when we were doing when we were checking our IP addresses for our home networks, we realized that most of ours come with a 192, 190 something because it lies here. All right. For Class A, there's no point of having so many hosts yet. Thank you, Leonard. All right. So most of our home networks have we're actually going to start from 192. Okay. And for programmers, most of you actually know you get to use this one. And somebody is unmute. All right. All right. Let me get you something quite important from this other class notes. All right. I'm going to find it for you and show you. But AWS has its own. All right, I'm going I'm going to look for you that fun fact, and then I'm going to tell you. All right. So now we have. I hope you've understood about the classes. Class A is between 10.0.0 all the way to 126, all the way to 255.255.255, and it's the largest because um you have 3 octets of the host that you can work around with. You have all these IP addresses, all right? We go to the middle network. We have 128. We skip 127 because it's of the local host. We go to 128.0.0 all the way to 191.255.255.255. Now this one is going to give you medium networks because you have 2 octets. Remember the first one was giving you 3 octets that you can get IP addresses from. The second one, you have 2 octets. The third one, it's from 192 to 23.255.255, and you have 1 octet that you can work around with. So, an example, let's say we have this example here. It's IP address of my network. It's 192.168.1.0, and somebody said he pinged somebody else's IP. I am scared of you people, Sai. You're getting too many ideas from the classes. So, if this is the IP address that we have, and we know that 192, we get to, we are given 1 octet, right? So, you're guided by the network, right? You know that you're going to get a subnet of 255.255.255.0, and you know that you have 1 octet that you can run around with, okay? And remember we said for each octet it runs from 0 to 255. Those are 256 hosts that you can get. But in each, the first one and the last one are not used because we cannot use the .0 or the 255. The 255, the last one, will be for broadcasting, and the .0 will be for the host. Okay, so we have 256, but we have 256 hosts, but you cannot use the 0 and you cannot use the 255. All right, so you can use between 1 and 254. All right. Um, so let's see how to calculate subnets. Let me see if this is a good idea. If it's a good explanation, I can go with. All right. This explaining what you are saying. Yeah. For example, we have our IP address. That one. All right. This one starts with the 127. All right. Let me just drop this down. Very nice. Okay. So let's say we have this my personal network of 192.161.1.0, and we know that this is in the class, it's in the class C, right? And if it's in the class C, we have 3 octets that are for the network and 1 octet that is for the host. So for the three, it will be 255.255.255.0 for the host. All right. And we've said that if we have the host runs from 0 to 255, because we said each octet has 255, all right? And even if it's starting from 0, it's okay, because it's going to run from 0 to 255 hosts. So in total, you're going to have 256 that you can use. But with that, we said that you cannot use the 0, the first and the last number. You remember last week when you were learning something, we learned that the last digit, the last 255, is used for broadcast. And broadcast is, for example, it can send, if you send any information, if you send any packet to this 255, it's going to broadcast it to all the IP addresses in your range. Okay. And we say the first one, it's for the network, so it cannot be used. It's for the network ID. All right. I hope you've understood. Now, when it comes to subnetting, and we want to divide this IP address, and we already know that it is like this. Um, Let me show you something kidogo right here. Uh, Let me see if I have it on the notes so that I don't jump it. All right, I don't think it's here. Just a second, I look for it. Yes, so I found it right here. So um let me just have it around. Let me just have it around here. and explain it to you from here so that you get to understand. So if you have a subnet like this one, if you're given, remember here we said that this is how the subnets are. And if you get a subnet that looks like this, let me just have it up here so that it don't mix you up. If you have a subnet like this one, it's 255.0.0.0, and you have another one of 255. So the second one should be 255, and this one should be 255.255. All right. So we said each octet, these four are all octets, okay? And you might get, because I do not want us to go to slider block notations without you guys understanding this. If you see a subnet that looks like this, it's 255.0.0.0. You might see them explaining it like having it as this is a /8. And you might find that when they have when a subnet has 255.255.0.0, so two parts of the networks, you might find them notating it like a 16. And if you have three parts of the networks, 255.255.255, you might see them noting them as base 24, a /24. All right. And this means that if a subnet has just one part of the network and the rest are for the host, it's just one. And remember that each part is an octet, okay? So the first one will show you it is a /8, okay? And then if it has two parts of the network, so it has a 255.255.0.0, it will be noted as a /16. So it's going to tell you that it has two octets for the host and two octets for the network. So base 16 shows you that two of these are for the networks, and /24 is going to tell you that three of these, see, you know guys, 8 times 3 is 24, 8 times 2 is 16, 8 times 1 is 8, sindio? So 8 times 1, it's 8. So if it's a /8, you're going to know that it is one octet for the network. If it is 16, 16 divided by 8 is 2. So you're going to know that two parts are for the networks. And if it's a 23, 23 divided by 8, you're going to know at 24, 24 divided by 8, it's going to be 3. So you're going to know that three parts of the subnet are for the network and one is for the host. All right. And this one is the largest because it will give you more IP addresses. You have extra three hosts that you can get IP addresses from. And the second one, which is /16, or it has two host parts, it's the medium one. It's going to give you a medium amount of IP addresses, so like half of what /8 would have given you. And then we have the smallest, which is which is a /24, because you're going to be given just one octet that you can get your IP addresses from. All right. All right. So let me ask you guys, if you see an IP address saying 192, all right, 192.168 dot say 5.9, or all right, .9 /24. What does it mean? You can just type for me the charts. What is the subnet of that IP address? What is the subnet mask of that IP address?
258.255.255.0.
Very nice. Yes. Very nice, Ivy, as well. Good. Yes, Ivy. Yes. What if you see this 10.5.9 /8? What is the subnet mask of the second one? Very nice. Yes, exactly. So thank you guys. Thank you for understanding that. So now let's say I have 192.168.5.9, and I want to subdivide this network. I want to split it into two smaller networks, into two subnets. Okay. Now I want to have this divided into two. All right. There's one thing that we can do. So because I want this divided into two, and we said that the subnet will be 255. I don't know if you guys can see my, let me just stop splitting this kidogo. All right. All right. So we know that the subnet for this will be 255.255.255.0/24. Okay. See, this is the subnet that you have. So now I want to subdivide it two into two subnets. So this is the IP address that I have, and I want to subdivide it into two. What we can do, we can come and borrow one subnet from our host. So you see now here we have an extra one. If I want to subdivide it into two, and we know that each octet gives us it gives us IP addresses host between 0 and 255. Sindio, 255 host. How many are these IP addresses? They are 256 hosts, Sindio, that I can work with, right? If these are 256 hosts that I can work with, I want to divide this 256 host into two. How many hosts will I be working with? What is 256 divided by 2? What is 128? Yes. So I'll be working with 128. Yes, exactly. 128 hosts per subnet. All right. So I'll have one 128 and another 128, all right? And the first one, I'll have two 128 hosts on each of the subnet. So the first host will be from 0 to 127, and the next one will be from, somebody tell me from, the next one will be from 120, to,
29.
all right, okay, here we're going to, it's this last part, it's not this one. So we need them to be 250 up to 255, because we have this the octet gave us host of 0 to 255. All right, we divide this into two. We're going to be given, the first subnet is going to have hosts from 0 to 127, and then the second one will proceed now from 127, which will be from 128 all the way to 255. Okay, have you understood why? Have you guys understood why?
Can you kindly repeat kidogo?
All right, so haya, here I have an IP address. Let me just delete this. We start afresh. So here I have an IP address of 192.168.5.9. All right, slash 24. Slash 24 tells me this IP address is in the class C. I'm only given three, uh, three, uh, three octets for the network and one for the host. Host is like your devices. It's like your printer, your computer, your laptop, your phone. Host. Those are hosts. Okay. Those are the devices. Those are the resources that we want. All right. Now, our network has this IP address of 192.168.5.9, and it has a side annotation of 24. Okay. 24 is going to tell you this IP address has 24 divided by 8 is 3. So it has 3 parts of the network. And then the last one, the fourth one, is for the host. Host is for your devices. These are the IP addresses that you can give out to your devices. All right. Now, if you want to borrow, or if you want to subnet your IP address, you want to subnet your network. Now, this particular network that we have right here, you want to divide it into two. What will happen is we are going to split this, all right? We're going to split this, all right? We're going to split it into two. Number one, I need you to understand two step by step. So between, and we know that this 0, even if it's a 0, it should be 255 of them, simply because each part of the octet is 8 bits, all right? And if it's 8 bits, all of them should run from 255.255.255.255. But we said if you are part of the network, if your part or part of your 255 is given for the host, it's given for the devices that you can use, it's going to have a 0. If it does not have a 0, that's for the network. You see, for example, like the first one, it has a 255. 1255. It shows you that the other three zeros, they're for the host, they're for the devices that you can work around with. Although all of them have 255, 255, 255, for you to be able to know the host for you to be able to know the devices or the IP addresses that you can give to your devices, networking, it made it easier for you to know by giving it a 0. Okay. So if any part you see a 255 or 255, you know that is for the network. If you see it at 0, it's for the host. It's for you. You can work around those. You can play with those IP addresses. All right. And if it's a 0, it doesn't mean that it has nothing. No, it's actually representing the 255 that you should give to your host. Okay. So this part here is a 0. It's the one that you've been given to work around IP addresses that you can work with. So even if it's a 0, it also has 255 of them. So what it means, it runs from 0 to 255. All right, it has 0 to 255 IP addresses that you can work around with. Okay. Now, if it has zero, it runs from 0 to 255. These are a total of 256 IP addresses. Sindio, if you count from 0, 1, 2, 3, 4, 251, 52, 53, 54, 55. Those are 256 IP addresses that you can have. Okay, all right. Because we can have 256 IP addresses, we want to divide our big network of 256 into two. All right. I want to have two subnets. In my example, I want to have two subnets. So what can I do? I will divide the 256 with 2, and I'm going to get what? 128. All right. All right. So this tells me that subnet A is going to have is to run.
Yeah, I have a question.
Yes. All right.
I have a question. We
Yes.
mentioned earlier that 0 is for the network,
Mm-hmm.
and the last one 255 is for broadcast.
Yes.
So I'm wondering why are we dividing 256 by 2 instead of 2? Is it 254? Because we already know 0 is for the network and 255 is for broadcast.
It's okay. It's okay. It's okay, Gideon, because we are still going to actually have that factored in. So you don't need to worry about that, because if the first subnet is going to run from 0 to 127, and the second one, subnet B, is going to run from 128 to 255, you see this 0 still remains near network, haitaguzwa. It will still remain for the network. And you see this 255 still remains for the broadcast. It won't be touched. You understand, Gideon? Okay.
Bado.
All right. So guys, we know that the first the first number is for the network, and the last is for the broadcast. Okay. So what it means is, even if we have, all right, so we know that this one totally it's a 255, sindio? Aya, pole Daniel. Let me go slowly. Aya, thing is, right here, kumbuka, even if iko na 0, let me just start from scratch. Even if it has a 0 on the notation on the subnet, it doesn't mean that it doesn't have anything. Okay. It has IP addresses, 255 of them that we can work with. Remember that all these should run from 255, 255, 255, 255. Do you remember, guys, uh, when I gave you a binary of, was it 10.255.255? 255.255, and you got the binary of these ones was 111. You remember? Do you guys remember? It was 11111, and then we had for the 10 exactly. So even if here you find, okay, the reason why we use zeros when it comes to subnetting, it's to show you which of the octet is for the host. It's for the devices that you're going to have. All right. Are you guys with me there? Even if the subnet has a 0, it is to show you this 0 is for the host. These are the IP addresses you can use for your host. All right. Now, let me remove this because you can remember. Now, because we've said that it is going to give you 255, here we know kabisa truly it's a 255, although it's showing us, this 0 is showing us that it is for the host. These are the IP addresses that you can work with. So I need to subdivide my network into 2. That is what we call subnetting. All right. Because I need to subdivide it, I may just need 2 subnets. I need a public subnet and a private subnet. But also for the 2, I also need IP addresses in each. So what do? I divide my network, and we said subnet is dividing your network into smaller networks. For Joy wants to have 2 subnets from her IP address. All right, her IP address has this subnet. All right, now you've been tasked to create for her IP addresses. You subnet it for her. She wants 2 subnets. Subnet it, divide the subnet for the network for her, give her her IP ranges. So what will happen is, you as Gideon and Daniel, you'll come and know that even if this is a 0, it actually represents a whole octet, and an octet, it runs from 0 to 255. Okay, because it runs from 0 to 255, it means that Joy has 126 IP addresses on her host. All right, are you guys with me up to there? All right. All right, because now Joy has 256 IP addresses and she needs 2 subnets, let us divide the 256 to 2 big chunks. All right. So if I have 2 big chunks, I have chunk A and I have chunk B. All right. Now, if I have chunk A and I have chunk B, chunk A is going to have the first 128 IP addresses, and the other chunk is going to have the other 128. All right. Now, the first 128, they run from 0 to 127. All right. And the second one is running from 128 to 255. And it is good that, Gideon, you're remembering that the first number is for the network and the last number is for the broadcast. All right. So now what is going to happen is, you see, I'm going to get for subnet A, let me just show you this. My subnet A IP addresses are going to run from 192.168.5.0, from 1 uh, 5.0 all the way to 192.168 dot 5.127. Okay, and then the other IP address is going to run from 192.168 dot 5.128. All right, all the way all the way to 192.168.5.255. So after I've subdivided my network, I'm going to get this range, okay? My subnet A is going to run from 0 to 127, and subnet B is going to run from 128 to 255. Okay, but then the first number of each IP, and the last one, the first octet, the first number of the octet is for the network, and the last is for the broadcast. So now here, this one, the 192.168.5.0 will be for this one here will be for the network. This IP address will be for the network, and this one will be for the subnet. Everything in between for the broadcast, sorry. And everything in between is what you can use for subnet A. And for subnet B, my first number, let me just copy paste this. Let me just start with this.
Excuse me, Joe.
Yes, Miss Embi.
If I may ask, in layman's language, what do you mean when you say for the network and for the broadcast?
All right. So you remember, Daniel, that we have the network and we have the host. Cindy, do you remember that? When we are
Yes.
saying, yes, I hope everyone remembers that we have for the network, like this one is for the network, and then these ones, the zeros, are for the host. Cindy. Now, also, remember that even if this one is for the host, it's also part of the network. It's also part of the network. So the first number will be attributed to the network. And for the broadcast, we said that the last digit, the last IP, ndio huwa inatumika. If you use that last IP, it's going to broadcast. Let me just give you a simple example. For broadcast, number one, if you go to your WhatsApp and there's somewhere that says, let me see if your WhatsApp has that. Let me see if our WhatsApp is gonna broadcast. Our messages, do you know they have? All right, if you go to your WhatsApp and you go to that hamburger menu, you'll see new group and then new broadcast. When you click new broadcast, it's going to give you a list of your contacts, okay? All the list of your contacts. So if you the contacts the contacts that you'll select, all right, those contacts that you'll select there are going, if you send a message to the broadcast, if you now select contacts who you want to broadcast to and send them one message, say you send them Merry Christmas and a prosperous 2026, and you broadcast it, all those people are going to receive the message, okay? So broadcast is going to send one message to everyone on that network, okay? All right, are you with me, Daniel?
I'm with you.
All right. All right, Justin, if you've understood up to there. So the 192.168.5.0, it's going to be identification of the network. It's going to be IP address of that network, all right? And Dot 127 will be for broadcast. So if you send a message to 192.168.5.127, it's going to send the message to all the IP addresses within this range. All right. Okay. Now, you guys tell me what will be the network IP for the second subnet for subnet B, and what will be the broadcast IP.
Come again.
Tell me, you see me, I've told you the network IP, the IP address for the network. For the first subnet, I've given you the IP address for the network and the IP address for the broadcast. So guys, tell me what will be the IP address for the network of subnet B and IP address for the network of the broadcast. Very nice. Very nice, Justin and Habakkuk. Exactly. Exactly. Very nice. Yes, Tony. Yes, Clinton. Yes, Habakkuk. Yes, Justin. So the network IP address for the first subnet will be 192.168.5.128. And for the broadcast will be the very last IP, which is 192.168.5.255. All right, that will be for the broadcast. And then now you can now use anything from 129 all the way to 254. All right. And for subnet B, for subnet A, you can use anything from dot 1 all the way to dot 126. Have you guys now understood? All right. I hope you guys have understood. Very nice. Very nice. And what address is reserved for the DNS? Which will get to there. Go to. Let me just take a glass of hot water for a minute. I'm coming back in the next like. Justin, how did we get to the subnet? All right. Oh, I understand your confusion. So earlier we said, I hope you guys can hear me clearly. So earlier we said there are several classes of IP addresses, all right? Now, class A, it starts from 10.0.0 all the way to 126.255.255.255. And its subnet runs from 255.0.0.0, which means it's a very large network because you are given three parts of the network of the IPs to be the host. All right. If it's class B, it starts from 127.0.0.0 all the way to 191.255.255.255. All right. And you're given two parts to be for the network and two parts to be for the host. All right. And for the third class, class C, it starts from 192.0.0.0 all the way to 223 .255.255.255. Then it's in the class C. Class C, you're given the default subnet mask of 255.255.255.0. All right, Justin, are you with me? Have you understood? All right. All right. So now, if we come and we subdivide so now because we have subdivided we have been able to subdivide our network, and you guys, I hope everyone has understood up to this point. If you've understood, let me know. Just write understood on the chat. If you didn't understand, write kindly explain or something. Musembe, you're good. I need everyone to understand. All right, very nice, very nice. um, Deheratu. All right, sorry for that. All right. So now anytime that you come in, all right. Nice, Juliet. Juliet, good morning.
Good morning.
Karibu kwa class.
Thank you.
All right. Naboth, good. Angela, good. Ivy, good. So now that you have understood, I do not want to go past this so that I do not confuse you. But let me see if I have anything more. Yes. So in a minute I'll go to the side annotations. All right. I want to go through so guys, anytime that you come and create a subnet of something, what will happen is you are going to give it a side annotation. Let me just get you some notes on side annotation so that then we can go to our lab and we can start our lab 263 for creating a subnet in a VPC. Let's start our lab 263, and then let me just finish up. I'll just use this example and I'll give you the notes. They'll be kind of easy to understand. I do not want you guys to read the notes in class. All right, now because you've had understood about now having one big network with one IP address like this one, 192.168.5.9/24, and we have subdivided it into two. We have subnet A and we have subnet B. All right, let me just bold this. So we have subdivided our network into two. We have subnet A and we have subnet B. All right, and we've said that subnet A we run from the network part will be .0 and the broadcast will be .127. The second subnet, the network part will be 128 and the broadcast will be 255. Now, remember that our IP address, was a /24. Okay, do you guys remember that? It was a /24, and this /24 told us that if it's a /24, we divide by 8, we are going to get to know the number of networks. All right, when we divide 24 divide by 8, we're getting 3, and three parts of the network, 3 parts of the IP are for the network. Do you remember? And we said if it's like that, then we have one part for the host. Now what happened is I came and told you that join needs 2 subnets, all right? And you subdivided it for me. Okay. So now what happened? You gave me these IP ranges, right? Starting from 192.168.5.0 all the way to .255. All right, give me these 2 different subnets. But then something that we left out was the slash. All right, so what happens is anytime that you come and subdivide a network, you're going to, all right, we call it borrowing in networking, but I'm going to tell you in an easier way, the way that helps me not get confused. So you remember that my side annotation when we were starting out, it was a /24, right? And we divided our subnets into two. Because we divided it, what happens is it now no longer becomes a /24. When you're writing this IP address, it will not be now /24. No, what will happen is because we just divided it one time and we got two subnets, what it is we're going to do, we're going to write a /25 because we have subdivided it, and it's also going to be the same for the second one. But let's say we come and subdivide these two further, and we divide each of these two further, and we get 4 subnets. The other two will be /26. Okay, and the lowest you can go, I think, is /30. It's the lowest subdivision you can get of a subnet. Have you guys understood? We call it borrowing, but I prefer to say that I just prefer I find it easier just adding one to the one major one, the one that I borrowed from. So from the parent IP, I borrowed one to get 25, right? And because I divided just once, I'm going to get plus 24 plus 1 is 25. So let's say we come and subnet A to 2 and we subnet B into 2, we're going to have 4 subnets. If you're going to have 4 subnets, those baby subnets are going to have plus now 1 from 25 will be /26. So let me give you a question. Imagine that now I want to subnet this further. I want to get subnet C and D from A and B. Let me say I want to get subnet C from A, and I also want to get subnet D from B. Guys, tell me the IP ranges, tell me the host and the network and the broadcast, and then write for me the side notation. So just like I wrote for you here, tell me it's going to run to what, and it's going to be /what. We can do the first one with you. What is 128 divided by 2? See, this one is this from 0 to 127, we have 128 IP addresses. Ndio, for subnet C, we have 128 IP addresses. Ndio. So if we divide it further by 2, if we subnet, how many IP addresses do I expect? For each, for now C and D, how many will I have? What is 128 divided by 2? It will be 64 exactly, right? So I'll have 64 here, and also I'll have 64 here. So for the first one, the first number of the network will be 192.168.5 dot what? .0. And then for the last one, the broadcast will be dot 64. And the third one for subnet D, it will be dot 65. And the last one will be dot 128. Now, what will be the side annotation? because I borrowed this one from 25, all right? Remember, I borrowed from /25. I've now divided it one more time. What will be the side annotation?
26.
Exactly, will be /26, right? Have you guys understood? Very nice. Very, very nice.
Question.
Let me give,
The last
yes.
broadcast on 27 or on 28.
So we have 128 IP addresses that we can work with, okay? Cindy, we have 128 IP addresses. So we know that it should run from 0 to 128, all right? The broadcast will be 128 for the last one, and the network will be 0 for the first one, right? And then upper katikati, it's where we divided. So we got .64 as the last part for the broadcast, and 65 will be now the network for subnet D. Okay, so the IP ranges that we can get for subnet C, the ones that we can now use are from 192.168.5 dot higher. Instead of now 0, because 0 is for the network, we're going to start from 1 all the way to 192.168.5.63. All right, and then for subnet D, we are going to have the IP addresses that we can now work with are 192.168.5. Yes, 64, 128 divided by 3. Divide by 2, sorry, Clinton. So the next one will be 66, because 65 is for the network. And sorry, and then for the next one will be, let me just get some space here, and for the last IP address that you can use will be 122.168.5.127. These are the ones that I can use. These are the IP addresses that I can use, all right, for subnet D. And for subnet C that I can use are these ones, and their side annotations are /26. Let me see chat. Clinton 63 or 64, but for subnet a broadcast it was 127. Oh yeah, let me just a minute, let me check. Yeah, this one was for, yes, we were actually to divide from, we were to subnet from 129. Just a minute, just a minute. Yes, Clinton. Thank you for the correction. All right. Yeah, so let me get a cleaner workspace. Let me just copy this to the last page. All right. Thank you, Clinton. Actually, yes, it runs from 63. All right. So here we started here for the 126. All right. All right. So thank you, Clinton. All right. Thank you, Clinton, for that. Yes. So we are starting from 0 all the way to 63 because we have 64 IP addresses. All right. We are subnetting we want to have 4 subnets. We want to break down the IP address to 4 subnets of base of slash 26. Sorry, people from my neighborhood today. So 128 divided by 2, we're going to get 64 IP addresses in each of the networks. This means that we run from 0 all the way to 63. These are 64 of them. These are 64 IP addresses. These are 64 IP addresses. So the host will be the network IP address will be 192.168.5.0 slash 26 all the way to 63. All right. All the way to 63. And then all the way to 63. But the ones that we can use are from 192.168.5.1 because we cannot use 0. We'll start from 1. So the first device is going to have a .1 and the last device is going to run all the way to 62 because now 63 will be for the broadcast. All right. And now for the second subnet, let me just write subnet 1, uh, subnet A, subnet B, so that you can understand. All right. So for the second subnet, it's going to run from the first one ran from 63 from 0 all the way to 63. So the second one is going to run from 64 all the way to 127 because those are 64. So the second one is going to have 64 IP addresses from after 63 it's going to run from IP address number 64 all the way to 127. These are the IP addresses that you're going to have in the second subnet. So the very first host will have IP address will be 64 all the way to, and the broadcast will be IP address number 127. the broadcast IP. So the range of IP addresses that we can have from here that we can use are from, instead of now 64, we're going to start from 65, which is going to be the first IP address on the second subnet, all the way to 127 minus 1 is 126, right? So what is going to be the other IP addresses for the next two? Remember, we are subdividing it into 4, all right? The first time we subdivided it into 2 and we got a /25. But if we want to have 4 subnets, we divide it into 4. So what are going to be the rest? Can we say B1 and B2? All right. So Habakkuk, you want the first one to be subnet A to be A1,
Yes,
or,
A1, then A1, then the other one will be A2.
then this one will be A2.
Yes.
All right. So now can I have the subnets for the subnet, the IPs for subnet B1 and also for the subnet B2. So this one is also going to have 64. And this one is also going to have 64. This one is going to run from, so from the last one here was 127. So this one is going to run from 128 Roy. Guys, let's first continue. The first one is going to run from 128 all the way to, what is it going to run to? It's going to have 64 IP addresses. So 128 all the way to,
Joy, I have a question about subnet A2. Why is it from 64 to 127 and not 128? It means subnet A2 will have 63, not 64.
come again, Gideon.
I'm asking about subnet A2. Why is it running from 64 to 127?
All right. Because we are counting the 64. We are counting number 64. So if you do 64, 65, 66, it's just like the way you can count between 1 to 64, 0 to 64. The 0 is being counted as well. Ndio inaanza kama number 1. Gideon, umelewa? All right. Yes. Yes, Justin. So subnet B1 is going to run from number 128. Remember hapa broadcast tuliachia kwa subnet A2 tuliachia 127. So for subnet B1 tutaanzia 128 all the way to, thank you Justin, to 191. All right. And how about the other one? So that can be easier, we do it pamoja. It's going to start from 192 all the way to the last one. Yes, to 255. Very nice. All right. Now, for subnet B1, the network will be, let me just copy this because I'll just grab. And I can copy this to here. All right. So because our subnet B1 runs from 128, the 128 will be the 128 will be the IP address of the network, and the 191 will be the IP address of the broadcast. So somebody tell me what will be the first IP address on subnet B1. It will be 192.168.5. Exactly Habakkuk 129. All right. And what will be the last IP address? It will be 192.1. No. For subnet A, for subnet B1, it will be 190. All right. Yes. And for subnet B2, it's going to run from 192.168.5. What will be the first IP address? The network will be 192 here, and the broadcast will be 255. Yes, it's going to run from 190 all the way to 193 all the way to 254. Very nice. Thank you, people. So that we have already now divided our big subnet, which was 192.168.5.9, which was a slash 24. We've subdivided it into 4 subnets: subnet A1, A2, subnet B1, B2. All right. And you guys, apart from Roy, I hope you guys have understood. All right. Remember that all IP addresses run from 255.255.255.255. All right. Even if it tells you that it has a host. So for example, let's say we're going to have a 0 here. It's going to show you that this 0 is for the host. All right. Msijali, niliwaambia, I told you guys from last week, mambo itaenda ikikuwa segemnegi kila siku. It's because that's why it's important. Roy, tomorrow you come here by 8:45. All right. So even if here we write a 0 for the class C, it still stands for 255. All right. Thank you, Gideon. So guys, let's go to our lab. We do a quick tour to the VPC. We see how to set up our VPC. All right, just restart so that you get additional time. It's the lab 263. Let me stop sharing. Now, let's go to our VPCs. Let me just start mine. So mine is ready. I just want to walk you through shortly on VPC so that you get to see how it looks like. And so that you can be able to even understand why we are doing all this. We are also going to, I'm going to also combine with the notes for last week. So I'm just going to share my entire screen, share my entire window. I'm just going to share my entire window, and I'm going to split screen with my console. All right. And we're going to learn a little bit about Amazon VPC. So Amazon VPC is the virtual private cloud that we have on AWS, where you can create your own network, and within the network you can have your own services. All right. Now, you guys, you have learned about CIDR blocks, all right, and you have learned about subnetting, and we're going to learn kidogo about route tables. You learned about API gateway and VPC endpoints. So let's just this we learned. All right. We can go to our VPC. Up here, search for your VPC. Search for the word VPC and click on it. As we are on this, I'd love to explain something small to you. Let me see if me. I'd love to explain this process to you, but in a simple way. So let me see. You just open my I hope you guys can see my screen. Hope you guys can see this Google Docs that I'm in. If you can, kindly unmute and let me know. How do I do this easily? So guys, imagine that you have a big network here. All right. Imagine that this is your network. All right. And you want to subdivide this network into 4, right? So we subnet our big network into 4. Okay. Guys, can you still hear me? Are you with me, guys? Can you see? Can you see my drawing? You can just unmute and let me know because I'm not seeing the chat. Can you see my drawing?
Yes.
Yes,
All
I can.
right. All right. So imagine that this is your network. Let me see. Can I even have like, yes, I can have a text box. So imagine that this is your VPC. Okay. This is your VPC, entire VPC right here. and we are going to subdivide it into 4 subnets, exactly what we've done. Remember, we are from subnetting our IP address to 4, right? And we got 4 4 subnets. Remember that this subnet had its own IP addresses from 0 to 63. This one from 63 to 120 something, this one from 120 something to 191, and this one from 191, 192 all the way to 255. So we had our subnets, all right? We've divided our big network into 4 subnets, all right? Now you can say that what you want is you want that these two, the boxes are too big, right? So you want that this subnet to be public, maybe a public subnet 1, and you want this to be public subnet 2, and you want this one to be private subnet. Remember that we said that I want this to be private subnet 1 and to have a private subnet 2. So imagine that we have our e-commerce site and we want to host it here. All right. Now we can say public subnet 1 can have an EC2 instance with our e-commerce site. All right. And then we also want to replicate the same on public subnet 2. Why? We want to have an EC2 instance here with our e-commerce site. Let's say that because we are going to the festive season, Merry Christmas, everybody, and we know that people are going to be shopping for their Christmas clothes. We know that there might be a hike in the number of people coming to shop on our e-commerce site. So I can have these two EC2 instances holding my e-commerce site inside the public subnet 1. So what it's going to hold, it's going to hold the web pages and maybe the photos or something, And then for my private subnet 1, I want it to hold the database, right? Maybe I have a MySQL database right here. I want it to be hosted on this private subnet 1. Why? Because I do not want people from the internet coming to access my DB. And maybe we can have subnet 2 for MySQL DB as well, or we can just use this for backup. All right, we can have this for backup, so it's going to back up everything for us. Now, you remember that we said private subnets, we can have public subnets and you can have private subnets. Public subnets can access the internet through something called internet gateway. Do you guys remember? Do you remember what an internet gateway is? Let me just push this down here. And we can have maybe like, let's just use, we can have the internet here. So this is the public internet. This is the internet that we are all using right now. All right. Now, for public subnet 1 and public subnet 2, for the public subnet to be able to access the internet, we need something called the internet gateway. All right. So we can have it like a line. We can have like a line here, the line here. And these two are going to get internet from the internet gateway, all right? The internet gateway, anytime that you come you come across something like a gateway, know that it is like a passage, it's like a gate, all right? And it is through this internet gateway that we can access the internet from our public subnets. And also for private subnets, we have something called a NAT gateway, all right? So I can have a shape here. Let's call this, let's see, can have like maybe an ellipse over here, and we call this a NAT gateway. NAT GW, a NAT gateway. Okay, so what happens on AWS is the public and private the public subnets can access the internet through the internet gateway, and for the private subnets can access the internet, like you might need to access the internet for you to be able maybe to perform your backups, to sorry, let me get another line there. All right. So for the private subnets to be able to access the internet, you might maybe need the internet on your private subnets, maybe to download something, to download updates on your instances, to download maybe pictures, something of the sort, to update your systems, to update your server, something of the sort. So if your private subnets need internet, what they will do, they will get something called the NAT gateway. All right. And this NAT gateway will then send the traffic on the NAT gateway. Okay. Excuse me. So the way that public subnets get internet is through the internet gateway. For the private subnets, we can go through something called the NAT gateway. And in some instances, people actually create, instead of using the NAT gateway, because it's quite expensive, you might find other people using one of you having created maybe an EC2 instance like this one. So let's say it's this one. Instead of now having it as an EC2, what they will have it is they will call this bastion host. A bastion host. So instead of going through the NAT gateway, they might come and use the bastion host. All right. All right. So there are ways that people architect their EC2 instances to be able to private subnets to access the internet. One of it is using the NAT gateway, but NAT gateways are expensive. So another way is through the bastion host. All right. So these are ways that you can actually access public internet through the for the public private IP addresses. All right. Now, for you to be able to route traffic, we need something called a route table. All right. And a route table is going to connect our IP addresses to the internet gateway all the way to the internet, or it's going to route our private instances to the NAT gateway, or route our private instances to the bastion host. All right. So that's the function of a route table. Let me see what we have else. I've explained to you about internet gateway. Now, VPC endpoints. um, VPC endpoints are, all right, you remember the story I gave you last week about an organization that needed that was using EC2 instances to that was using ECS, or even just let's say EC2 instance. We want our EC2, our e-commerce site here, to access S3. All right. Let's say we want now our EC2 instance to store images or maybe to even pull up images from an S3 bucket. Okay. And we can have, let me just have S3 here. Let me call this S3. I don't take it fast so that we can all relate. So guys, this is our S3 bucket right here. Now we want our public EC2, we want our EC2 commerce to be able to pull up images from S3, and then users can be able to see our e-commerce site. So how can we do this? What we can do, instead of going through the public internet and then to the S3, what we can actually do is we can use AWS's private network, okay? And what we can do, we can connect the EC2 instance to the S3. So do it. Let me see. Let me see the type of arrows. Yes. So what we can do, we can connect S3 to our VPC, to our EC2 instance, our EC2 instance here. We connect it to S3 via a VPC endpoint. Okay. So imagine this as the VPC endpoint. All right. This is going to ensure that EC2 can access our information on the S3 via the VPC endpoint inside the AWS cloud without having to get to the internet. And this is going to actually be free to get images. And remember, we say that for data from AWS, it's costly. It's being charged per, I think it's GB or MB. So it's being charged. So because we do not want to be charged for getting anytime we pull up images from our S3 bucket, what we do, we can just use a VPC endpoint. Okay. Hope you guys have understood. So that is what we call VPC endpoints. They help you connect different AWS services without needing the public internet. All right. I've explained to you about the NAT. All right. And guys, remember, let me clear up about knuckles and and security groups. We said knuckles, network access control list. Network access control list. Networks is the security of the subnets. So this one can have its own knuckles. The subnets can have their own knuckles. But when it comes to EC2 instances, they are protected using what? Using security groups. All right. Security group is the firewall of your security group is for the EC2 instances. It's for the instances, but knuckles are for the subnets. And you see, a subnet, you can have several things. You can have your EC2 commerce site here. You can have your RDS running here, your database, different things. So to secure your subnet, you're going to use knuckles. To secure your EC2 instance, you're going to use security groups. All right. Have you guys understood? Have you guys understood? All right. Exactly, Salem. So a bastion host is one of the ways that you can actually access instances in the private subnet. Now, I think now we have a good understanding of VPCs. Let me see what we skipped. We've gone through route tables, private and public, security groups, knuckles. All right. So these are the services that you can actually have them on your subnets. So you have OpsWork. This one is for running like cron jobs, things that you want to automate. EC2 auto scaling, because yes, you will have EC2 instances there. All this we're going to learn them later when we get to services. All right. So I think I can stop splitting and share my. Let me stop sharing. Share just the console. All right. So guys, I doing demonstration. All right. So this is your VPC, all right? And you can access all the things that we talked about. They are here. So you can access your subnets, your route tables, your internet gateway, your knuckles and security groups, your VPC endpoints, your all these other things you might not need them for now. For now we might not need them. So we can do a short demonstration. I do not think we have to do, let me see what the lab is about. Let's see if we should do it here. Right, so we'll not do it's more of your explanation. So let's go through a VPC. We can try and create a VPC. All right, so are you guys on your VPN console? Kindly type on the chat you're on a console so that we move together. We do this for the next like 10-20 minutes, and then we release you to go to your groups. Tony is there. All right, very nice. Very, very nice. So, for a short run through, let's just create. So, VPC and more is a short way to set up your VPC. Most things will be done for you. So, as you can see here, when you click create VPC, there are two ways that you can create. So you can create a VPC only, and you can create VPC and more. VPC and more is a bit easier. Everything is done for you. So you're going to give a name to your VPC. You're going to be given an IPv4 address, a CIDR block. And we said we do not really need to use IPv6 for this case. And you see, the CIDR block that you've been given is 10.0.0.0. So you have a lot of IP addresses. Actually, you have 65,000 IP addresses. You can choose the number of availability zones that you want. So like on this case, we have 2 availability zones. And guys, remember the importance of having availability zones, multiple availability zones. Multi is to ensure high availability of your architecture. All right. You can have you can select the number of public subnets that you want. For example, if you want 2 public subnets, remember that us in our case we had 2 public subnets and 2 private subnets there. And you can decide whether you can have a NAT gateway. And guys, what did we say a NAT gateway is for? Anybody? We said a NAT gateway is for what? A NAT gateway. Let me see what you people are saying. Yes, it's to connect your private. It's actually to connect your private subnets to the internet. So the connection will be from private subnet to the NAT gateway to the internet gateway, then to the internet. All right. Yes. Yes. All right. And you can decide whether to have a NAT gateway or not, but it is really, really costly. Very, very costly. All right. Then we can have VPC endpoints. So remember that we said in our e-commerce site, we can want to have our, yes, thank you. All right, so we say that we might want to, when we're having our EC2 instance and we have data stored on our S3, we want to pull that data to our EC2 instance so that people can see it. What we can do, instead of going through the public internet, we can connect VPC endpoints to the S3. All right, so you can actually connect with an S3 gateway. And DNS, it's optional. You can either have it or not. So this is the easiest way of creating your VPC. All right, VPC and more. Now on the VPC only, you can give your VPC a name. Right, for example, you can just use VPC1 because we can just use or even just say my VPC, my dash VPC, and you can give your IPv4 CIDR block. So for example, like earlier, we had 10.0.0.16. Here, we can have 10.0.0.24 slash and they're actually telling us that your CIDR blocks must be between 16 and 18. So you can go with just 24 because you do not need a lot of IP addresses. No, we said IPv6, we might not need to use it on our on our course for solution for CCP, but it's okay. And then you can create your tag. Now, if you're going to launch your VPC only, remember that you need to have your internet gateway, you need to have your route tables, you need to have your security groups, your knuckles, your private subnet, your public subnet, all those things. Let me just consult a minute.
Is Joy supposed to speak?
I'm also worried.
Hello, Joy.
Guys, sorry for that. I was consulting Patrick on what we should do regarding this. So for this lab, for this class, we're just going to use VPC and more to create our own VPC. But now in the afternoon, when Patrick comes, he's going to take you through to VPC only because it's quite long, and my time is up with 30 minutes. So let me just show you how to create VPCs using VPC and more, and then we can break to our groups. All right. Sawa. So when you want to create a VPC easily and fast, and you want everything automated for you, what you can do, you go to your console and search for VPC, and you come to create a VPC using this tab for VPC and more. All right. So for VPC and more, you can give your name. You see, they even also generate a name for you. You can just call it something like my VPC. All right. And once you give it your name, then you can select your CIDR block. So for example, like this one is 16, maybe you can go with 24. You can go, and for 24 it gives you 256 IP addresses that you can work around with. All right. So remember, this is what we did, and we said the first one, we do not touch it. 10.0.0.0, we do not touch it because it's for the network. And for the last one, 10.0, 10.255.255.255, we do not touch. 10.0.0.255, we do not touch it because it's for the broadcast. So the first one, we do not touch it. So even if you have 256 IP addresses, normally you'll have the IP addresses that you can give to your resources, to your host, are 254. So the CIDR block, it gives you the number of IP addresses that you want to provision, that you want to work around with on your network, right? And we said for this course, we are not going to deal with IPv6 because it's really not as important for this course. Now, tenancy, you can just let it stay on default. Tenancy, you're going to learn it when you get to the services because it's for example, like dedicated is more costly and it is just for you alone, but just leave yours as default. All right. For the number of availability zones, remember, guys, we've said if you have multiple availability zones, either 2 or 3, it's going to ensure that when one availability zone is down, the other 2 or the other one is holding your entire instance up. And then, just a second. All right. All right, no problem. All right. So the availability zones, you can have your VPCs can span into various availability zones. So if you want to have one availability zone, for example, if you're just doing your test practice, or it's just for testing, or even just staging, nothing important, you can have one availability zone. But for your for your production, ensure at least you have 2 or 3 availability zones to ensure that when one AZ is down, remember, like when one AZ is down, the other two AZs can hold your system up and it won't be down. All right. All right. So the number of public subnets, we can just have one, and private subnets, we can just have one in our case, or even none. We say that for private subnets, this for you want to host something that you do not want the internet to access it. For example, like your database. So if you do not have a database, there's no really point of having a private subnet. But if you have for example, like a database or a backup, or something running into, or even another EC2 instance for maybe something you do not want it to be accessed through the internet, you can have it on your private availability zone, on your private subnet. All right. Now, for the CIDR blocks, remember here, they've created for us uh, two two subnets, one for the public subnet. So many subnets do I have? I have one public and one private. Yeah. So they've created a subnet for us, and for the public subnet, it's going to run through this IP address. I can have 16 IP addresses with this CIDR block, and for the private subnet, I am given this CIDR block. I also have access to 16 IP addresses. Now for the NAT gateway, guys, we said NAT gateway, it gives access of your private subnet to the internet. So what happens? Remember, guys, we said it's from private subnet to the NAT gateway to the internet gateway to the public internet. If you're on the public subnet, it's just through the internet gateway and then through the internet. There is no other way of accessing the internet away from just using the IGW. That's the major route for the internet. All right. And then we have the VPC endpoints. And we said the VPC endpoints, they're the ones that helps you to connect, for example, to your S3, to your EC2 instances. And we said if you have a site that, if you have an EC2 instance that needs data from the S3, instead of going through the public internet, which will be costly, you can use the VPC endpoints. All right. And if you have this and you think this is ready for you and good for you, what you can do, you can just go and create your VPC endpoints, and you're going to, you can create your VPC, and you're going to see the entire process flow running just for you. You've been created for. So in our case, we've been given IP addresses, we've been given a DNS host name and resolution. They've enabled it. Um, hmm, we have an S3 endpoint, so we can be able to access S3 bucket through our VPC. They've created for us a public subnet and a private subnet, and also an internet gateway for public subnets to be able to access the internet. And they have attached it to our VPC, and then they've created for us a route table. Remember, I told you a route table is going to help you create routes. So for example, you see the route I'm telling you for the private subnet. So from the private subnet to the NAT to the AGW to the to the internet, all these routes are created on the route tables. Sorry. Then the other thing is they associated the S3 endpoint to our private subnet route tables. So in the next class, you're going to learn how to do all this by yourself. You're going to do this practically by yourself. And once you're done, you can be able to see your VPC, and you can now go ahead and maybe launch your EC2 instance. Remember where when you are launching an EC2 instance, when you're launching your EC2 instance, and kuna hiyo place ya network, and we were editing network where you choose lab VPC. Do you remember when you were launching an EC2 instance and you go and choose edit, and then when you edit you see lab VPC, and they had done a very good job of creating for you a lab VPC. So now, with this knowledge, you can actually, when you're creating your EC2 instance, you can go and now select your own personal VPC that you've created for yourself. All right. Let's just see if it's going to come here, and then we're going to end the class. All right. Just a second. it finishes loading up. Let's just give it some time. Yes. All right. So when you come to edit your VPC networks, and you can see the VPC that I created, my VPC, it appears right here. And I can even see the IP address that I chose in the CIDR block. Can you guys see? So now instead of now going and saying, I do not have a lab VPC, you can create your own personal VPC right now, and you can now use it, right? Very nice. So guys, if you have understood that, I do not want to confuse you anymore. So that is the end of my class. That is the end of my class. I hope you guys really understood about subnetting. Roy, I'm going to have a private meeting with you, and I'm going to explain to you about the subnetting. I don't want you to be left behind. And then thank you guys. I hope you enjoyed the class. I'm so sorry that it is tough. I know networking is not for the faint-hearted. I also took quite some time. For the lab, I just wanted us to use the lab to try and launch a VPC, but we have not done the labs. Patrick is going to explain to us what we can do. And guys, that's the end of my class. Kindly give Patrick a few minutes. He can give us an announcement, and I'll see you guys in the afternoon. Patrick?
Hi. Hi, thank you so much, Joy.
Stop recording, Patrick.
Oh, sawa. Tap.